This is Lesson 9A, Unit Rates and Equations. We've been working a lot on the idea of proportional relationships and unit rates as of late. So today we sort of continue with that idea. Our daily learning target is that you will be able to use an equation to find missing information. If we have any shoulder partnering, you will be able to explain in words the process of determining an equation using the correct vocabulary, proportional relationship, equivalent ratios, and constant of proportionality. One of the reasons why you are learning this is figuring out the amount of time to do a job. Make sure you've got your blank areas filled in there. And remember, always pause the video if you're watching at home if you feel like I'm going a little too fast. All right, and as usual, we start most lessons out with a little bit of background knowledge to refresh your memory on some of the things that we've done in the past that are important for today's lesson. We typically use the variable k to represent the constant of proportionality. We can find k by finding equivalent ratios in a table or by locating that very important ordered pair, 1 comma something on a graph. That something, that value where a k would be there, that's the constant of proportionality also. The equation for a proportional relationship, which we have talked about in the past, is of the form y equals kx, where k is the constant of proportionality. And you may remember sometimes we use different variables than y and sometimes different ones than x, but the constant of proportionality always goes right there. So let's take a look at number 1, and this is another calculator day. As you can see the picture of the calculator on the right-hand side of the screen there. So this table shows bamboo height per a certain number of days. That part in red there is extremely important because that means that the input is the time in days, and the output is the height of bamboo in centimeters. In other words, you can't find the height unless you know how many days it's been growing. So, is this a proportional relationship? How do you know? Well, we're going to do number 1 together. It is a proportional relationship. And the reason that I know, or one way that I know, is if we take all the ratios of the outputs divided by the inputs, in other words, the bamboo height divided by the number of days, they will all be equivalent to each other. Because 120 divided by 2 is 60. 180 divided by 3 is 60. And also, 360 divided by 6 is 60. They are all the same. They are all equivalent. Therefore, that is a proportional relationship. Now, we've also talked about that same idea in terms of the constant multiplier, but it's the same idea. The constant multiplier is all multiplying by 60. You're multiplying each of the inputs by 60 to make the output. That's just another way of looking at that. Part B, what is the constant of proportionality? Well, the constant of proportionality is 60. It's the constant multiplier, or it's what we got when we used those ratios and simplified all of them. And we would usually say that it's k equals 60. All right, so the next question is, what is the unit rate? Well, remember, the constant of proportionality is always part of the unit rate. It's just missing the units for that particular rate. And it is 60 centimeters per day. As far as the units go, remember, it's always the output per the input. The output per the input right there. You could have also, I guess, found it right here as well. All right, so we've got the constant of proportionality. We've got the unit rate. What equation represents this relationship? Well, first of all, we need to make sure we're checking to see if we're supposed to use other variables other than y and x. And, of course, we're supposed to use h and t. And so the equation should be h equals 60t. We know that h goes on the left. There are lots of ways of figuring that out, but that's the height. That's the time. You could have also seen that right here. But it should be h equals 60t. In order to find the height, you have to multiply the time by 60, and then you will officially have the height. Part E, which is a new thing for today. If the height of the bamboo is 300 centimeters, how many days did it take? Well, one way of looking at this is it's really just kind of like if we added on another section in our table here, and this is 300, the question is, what would the time be? Well, there are lots of different ways of figuring that out. You could be thinking about, well, what number do I have to multiply 60 by to make 300? We've also talked about the idea that if you go backwards, which is technically what we're doing here, that you would do the inverse operation to multiplying by 60. And if you have forgotten, that means dividing by 60. And so 300 divided by 60 is 5. And that should kind of make sense. If it took 6 days to grow 360 centimeters, it will only take 5 days to grow 300 centimeters. We could also utilize the equation as well. And so, if we are given 300 centimeters, that is the height. So we would replace h with 300 and then solve that very simple equation. That's just another way of figuring out that the amount of time would be 5 days to grow 300 centimeters. So always lots of different ways of finding what we need. Okay? All right, and then we have a part F. If you were to graph the values in the table, what do you expect it to look like? Well, we already stated that this is a proportional relationship. Remember, all graphs that are proportional are linear. In other words, we have a line and they have to go through the origin. So all we're really doing today, putting everything together, adding on that one part, new part, which would have been part E. Okay, let's take a look at number 2. Number 2, the graph below shows the cost in dollars per a different number of books. And you can see that in the graph that's right below that. Okay, first question A, part A. Is this a proportional relationship? How do you know? Of course, it is a proportional relationship because we have a line and it goes through the origin. In other words, it's linear. Remember, linear just means we have a graph that is a line, and it goes through the origin. Okay? Part, well, before we go on to the next part that you're supposed to answer here is the equation, and the equation is y equals 4x. Now, how do we know that? Well, I gave it to you. It is y equals 4x. What is the constant of proportionality? Well, it should be obvious, hopefully, that right there is the constant of proportionality. Okay? All right. What is the unit rate? Well, we know the unit rate is going to be 4 something. This is where we bring in the labels here. And it's always output per input. Sorry for the writing there. Output per input. So that means it's going to be $4. The output is the cost in dollars. The input is the number of books. So $4 per book, not 4 books per dollar. And I'm just kind of showing you where I got those parts of the label for the unit rate. And from graph labels, it's always y-axis per x-axis, output per input. Let's go to number 3. Here we have a table. The table shows 4 measurements of the amount of dirt excavated. Excavate means you're taking dirt out of the ground, digging a hole, per the amount of time it took in hours. So notice that I've labeled the input and the output. Notice also that I'm using H to represent the hours worked, Y to represent the yards of dirt. Is this a proportional relationship? How do you know? Well, you could think about it in terms of the constant multiplier if you want to. You could also do the output divided by the input, which is what I'm going to do. The yards of dirt divided by the number of hours worked. When we simplify all of those ratios from the table, They all are equivalent to each other. So that means it has to be proportional. In fact, they all simplify to 6. And then another way of looking at that is that the constant multiplier is 6. So yes, it has to be a proportional relationship. What is the constant of proportionality? Well, all of these ratios simplified to 6. The constant multiplier is 6. Therefore, the constant of proportionality is k equals 6. Next part, what is the unit rate? Well, we know it's going to be 6 something, but remember, as far as the units go, it's always output per input. The output is yards. The input is hours. Therefore, the unit rate is 6 yards per hour. What is the equation? You have to focus on the variables that are found within the table. So that would be y equals 6h. Part E, if the number of hours worked is 8 hours, how many yards of dirt did they excavate? Now, you could use the equation. You could also just add another section in your table here, 8 hours, and then figure out that. It's up to you how you want to do that. I'm going to go with the equation. So we're going to replace h, because hours is represented by the variable h, with 8, and of course we get 48 yards of dirt. All right, I think this is the last problem for today. Number 4, the graph below shows y values per x values. Is this a proportional relationship? And of course it is. The graph tells us that it is. It's linear and through the origin. The equation for this relationship, I'm going to give it to you. It's y equals 1/5 x. What is the constant of proportionality? That should be obvious. It is k equals 1/5. What is the unit rate? Well, this one's a little bit tougher as far as the units go, but anytime there are no labels other than y and x there, remember it's always output per input or y per x. In this case, it would just have to be 1/5 of a y per x. I know that seems silly, but that's what it would be. And once again, from the graph labels, it's always y axes per x axes. If there is an ordered pair with an x value of y on the graph, what is the y value? Well, what that means is, this graph will continue on and on and on, but what would the x value, if you're at 35 right here, what is that y value over there? Well, this is another one where it makes sense to use the equation. So we're going to replace x with 35 because that's what it states that it is. And so we have 1/5 times 35, and that is 7. That would be the y value. All right, that is it for today. Think about what you learned today for a few seconds. And of course, today our focus was on unit rates in tables, and also we dealt with using equations. That is it for today.